So we have worked out our reactions at the supports, and both of those were equal to 40 kilonewtons. And like I was saying, or like I chopped off in the last video, because this is a symmetrical truss, and we know that the distance from here to here is 10 meters. We know that this is 60 degrees because it's a Warren truss, it's an equilateral triangle, and we know that that intersects at halfway, so we would have 5 meters here. And we've worked out our reactions at our supports, and we now need to solve, we're looking for 3 joints, okay? We were looking for, it's always nice to write up here what we're looking for. For part 2 of the question, we were looking for the joint AB, the actual force, and whether it's in compression or tension. We were looking for AC, and we were looking for BC. And we're going to use a method of joints to do that. This is probably the simplest question that you could possibly do for method of joints. And by no means is it completely simple. There's still stuff that we need to do, but this is about as simple as I can make it. So we're going to start at joint A. We know that with joint A we've got 2 unknowns. It's sometimes helpful to think of with these problems, what we're going to do is we're going to basically cut through these members and isolate them. Okay, so create separate joints. So we'll start with joint A. Joint A. And we're going to draw our actual joint. So we know that at joint A we've got 40 kilonewtons coming up, which is our reaction at our support. We've got this force here, which is force, let's have a look here, AB, which is going to be the tension or compression in that member AB, which is this one here. We've got force AC, which is tension or compression in this one here that we want to find out. And then when we do the next joint, we'll find out the other one that we need. And we know that we've got an angle of 60 degrees because it's an equilateral triangle. So what we're going to do is we're going to find, first of all, the sum of forces vertical and horizontal. So sum of forces vertical we'll do first is equal to 0, because this whole joint that we're looking at, joint A, is in equilibrium. So we then say 0 is equal to, and we're looking at 40 plus 40, because it is going up, which is positive direction, plus FAB times sine 60 degrees. Now, we know it's FAB times sine 60 because we're looking for the vertical component of this angled force. And that's resolving forces, and we've done another page on that. So if you don't know how to do that, go to modules and find out resolving forces before you do this exercise. You really need to be able to do this. And then we're going to say, we're going to find out FAB. We're going to take it, we're going to leave it on this side of the equal sign, so you need to take this over the other side. So we're going to end up with a negative value, negative 40 divided by sine 60 when we make FAB the subject of the equation. So we end up with FAB, when we do our mathematics, is equal to minus 46.2 kilonewtons. Okay, and because it's a negative value, we know that that member is in compression. So we've got our AB value, so we can put that in here now. Okay, up in the AB, 46.2 kilonewtons, and it is in compression. Okay, so we've already got our first answer. Okay, member AB is in compression. And then what we're going to do is we're going to do our horizontals to find this one here, FAC, that we don't know. So we're going to go to the right. Force is horizontal, so to the right is positive. Force is horizontal is equal to 0. And we're going to say 0 is equal to FAC, because we know that that is a positive value because it's going to the right, minus cos 60 times 46.2. Now, why have I said minus cos 60? Because when we actually worked out that our member FAB was in compression, what we needed to do was turn this arrow around, okay? Because once we find out it's in compression, the arrow is pointing the other way. So once it's pointing the other way, this horizontal component of the FAB force is going to be pointing to the left, which makes it negative. So you've got to make sure that if you find that a particular force is in compression, that you reverse that arrow. If you forget to do that, you will get the wrong answer. So when we solve our FAC, okay, we get FAC is equal to 23.1 kilonewtons. And the FAC value, because it's a positive value, because when we take this this negative value over the other side, it becomes positive, we're going to know that that member is in tension. Okay, so 23.1 kilonewtons in tension, FAC. So we can go up to a little box up here, and we can say 23.1 kilonewtons tension. Okay, now I've drawn this box completely too small, so I'm going to rub it out because this is really bad setting out, and I'm going to say I'm going to basically rewrite my answers. So the first answer we got was FAB, so I'm going to say AB is equal to 0.2 kilonewtons compression. And then our second answer, AC 23.1 kilonewtons in tension. So we've already found two of the values that were asked for this question. We've only got one left to find. And the last value we need to find, we can use joint C to find. So I'm going to go down to the next page. I might stay on it. Will I be able to fit on this page? We'll probably be able to fit it on this page. So we're going to say joint C. So we're going to draw joint C. And we know that with our joint C, we have the same reaction at the support, which is 40 kilonewtons acting up. We know this force going this way, FCA, is the same as FAC, which we've already worked out. So we know that's 23.1 kilonewtons. So we've already worked that one out, and it's in tension, so it's going away from the joint. And then the last one we want to work out is our FBC. Okay, so that's the only member, FBC, that we're missing. And FBC, of course, is the last part of the puzzle that we need to solve. So we can once again go sum of our forces vertical is equal to 0. And we go 0 equals, we've got our 40 kilonewtons here acting up, plus, because this FBC is acting up this way at 60 degrees, we go plus sine 60 times FBC. And what happens is when we take this 40 over the other side of the 0, we're going to end up with sine 60 FBC equals minus 40. And then we divide by both sides by sine 60. So FBC, when we solve, it equals minus 40 over sine 60. So FBC is equal to minus 46.2 kilonewtons, and because it's a negative value, it is going to be in compression. So as soon as we know it's in compression, you need to make sure that you reverse that arrow, okay, and point it towards the joint. Because if you were doing a method of joints problem that had lots and lots of joints, if you forget to turn that arrow around, you're going to get the wrong answer. So minus 46.2, so we're going to go back up here, and we're going to say BC equals 46.2 kilonewtons, and it is in compression. And that is our answer. So we've just done probably the world's most simple method of joints problem. Have a go at doing the problem on your own, and just remember that you assume that a joint is in tension, which means the arrows are pointing away. If you find out that they are pointing towards it, you make sure that before you proceed with any calculations that you go on with, that you actually reverse the arrow and make it correct. And if you do all of that, your answers should come out correct. So do this problem until you get it correct, and then tackle one of the problems further through this module that are a little bit more complex, and you should be able to do these problems, method of joints, without too much hassle. See you in the next video.